So now we're looking at lines. So after this section, you should be able to calculate and interpret the slope of a line. You should be able to graph lines given points and a slope, or a point and a slope. You should be able to find the equation of a vertical line. Use the point slope form of a line, identify horizontal lines. Use the slope intercept form of a line. Find the equation of a line given 2 points, graph lines written in general form using intercepts, find equations of parallel lines, and find equations of perpendicular lines. So calculating and interpreting the slope of a line. So when you walk upstairs, there is a certain steepness to them. The steepness can be calculated using the term slope. The slope is a numerical measure of steepness of a line and can be found as following. Okay, so if you're given 2 points, let's call it point P, x sub 1, y sub 1, and point Q, x sub 2, y sub 2. So let them be distinct points. That means that x sub 1 does not equal x sub 2. The slope m of a non-vertical line P and Q is defined by the following formula. So we have y sub 2 minus y sub 1, so the change in our y value, all over the change in our x value, x sub 2 minus x sub 1. If x sub 1 does not equal x sub 2. So if x sub 1 equals x sub 2, we have a 0 in our denominator, and that's undefined. If we do have x sub 1 equals x sub 2, then it's actually a vertical line. So if x sub 1 does not equal x sub 2, then L is a vertical line. I think that was meaning right here. This is not right. This should be if x sub 1 equals x sub 2. Then L is a vertical line, and the slope m of L is undefined, since this result is dividing by a 0. So another way is describing the slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. It doesn't matter what point you start with. This is the same thing as y sub 1 minus y sub 2. But if you start with y sub 1 as your y value, then in the denominator, you have to start with x sub 1. So all over x sub 1 minus x sub 2. This is equal to the change in y all over the change in x, and we can denote the change in y with a triangle y, and the change in x with a triangle x. Okay, so you might have also heard this as rise. How much are we rising? All over the run. How much are we running over, left or right? So let's look at an example where you're given 2 points and you want to find the slope. So let's say that you're given the point -5, 4, and 0, 7. Find the equation of, or find the slope. Of the line between those 2 points. So we're looking at the change in our y value. So 7 minus 4. So since I started with the second point that I listed, in the denominator, I need to start with the second point for my x value. So I would have 0 minus -5. So simplifying, 7 minus 4 gives me 3, all over 0 minus a negative 5 is positive 5. So my slope is 3/5. So I would rise, if I had a point on the graph, I would rise up 3 and over 5. Well, actually, we have 2 points on the graph, right? So we have this point here, 0, 7. So just go up 7. And so I could get another point on this graph if I rose 3. So 1, 2, 3. So I would have a y value of 10, and I ran over 5. So if I rose 3 and ran over 5, that would get me a point right here at 5, 10. Notice that I could make this a negative 3 over a negative 5. So I could go down 3 from my point and over 5 to the left. And that would give me another point on my graph. And so we actually found, or the graph, given those 2 points and knowing what the slope was. So knowing if our slope is positive, if it's negative, if it's equal to 0, if it's undefined, tells us what our line is going to look like. So when the slope of the line is positive, the line slants upwards. So I think of it as if I'm walking left to right, I would be going uphill. If the slope of the line is 0, the line is down. I'm sorry, that's not true. I was thinking, I thought it was going to say negative. When the slope of the line is 0, the line is horizontal. This is when we're going to have something in the form of y equals k, where k is equal to a constant or a real number. When the slope of the line is negative, the line slants downwards. So thinking of it, we are moving left to right. We read left to right in this country, that the line is going downwards. If I was walking on the line left to right, I'd be walking downhill. And when the slope of the line is undefined, the line is going to be a vertical line. Your equations, if it's a vertical line, is in the form x equals some constant k, where k is a real number. So the next example says, let's draw the graph of a line that contains the point -1, 2, and has a slope of 2. So let's first plot our point, -1, 2. So we're going to left 1 and up 2. For part A, it tells me my slope is 2. Well, notice that's not a ratio of 2 numbers. We can rewrite it, though, as a ratio of 2 numbers. 2 is the same thing as 2 over 1. So that tells me from the point that we're given, we're going to go up 2, and then we're going to run over 1. So that would get me a point at 0, 4. So I could go up another 2, and then run over 1. and that would get me a point at 1, 6. I could look at the slope of 2 is the same thing as the slope of -2 over -1. So instead, from my point at -2, I'm sorry, -1, 2, I could go down 2 and then to the left 1. And that would get me at -2, 0. I went down 2 from there and over 1 to the left, I'd have a point at -3, -2. So again, knowing what the slope is and 1 point on the graph, we can get what the graph of the line looks like. So the next example, same thing, we have a point at -1, 2. So left 1, up 2. But this time our slope is -4/3. Well, there's 2 ways that we can think of -4/3. It's the same thing as -4 over +3, or it's the same thing as +4 over -3. So let's look at the first one, -4 over +3. So that would tell me I'm going down 4, but over 3 to the right. So if I went down another 4 and over 3 to the right. That would get me at 5, -6. Or I could have gone up 4 from -1, 2. That would have gotten me 6 and over 3 to the left. That would get me at a point at 4. That would get me at -4, 6. And then we can draw the line that goes through those. This next example deals with graphing vertical and horizontal lines. So if you have x is equal to -4, well, notice there's no y value there. So it doesn't matter what x is. We're always going to, sorry, it doesn't matter what y is. We're always going to get x is -4. And so here, if y was -2, x is -4. So we have -4, -2 is a point. When x is -4, y is -1. -4, 0 is a point. -4, 1 is a point. -4, 2 is a point. So it doesn't matter what you plug in for for y, x is always -4. So this gives us a vertical line through x equals -4. Y equals 2. So it doesn't matter what x is in this case, y is always going to be 2. So if x was -2, y is 2. If x was -1, y is 2. If x is 0, y is 2. 1, 2, and 2, 2. So we have a horizontal line here through y equals 2. So equation of a vertical line theorem. A vertical line is given by the equation of the form x equals k, where k, in this case, is the x-intercept. If you have a horizontal line given by the equation, let's say y is equal to k, then k is going to be the y-intercept, where k is a real number. So there's different equations of lines. So the point slope form of an equation of a line, an equation of a non-vertical line with a slope m that contains the point x sub 1, y sub 1 is y minus y sub 1 is equal to m all times the quantity x minus x sub 1. So you would go in and you would plug in your value for your point x sub 1, your value of your point y sub 1, and you would plug in your slope of m. And then you would have the equation of the line in point slope form. I normally don't use this one because I can always do it by knowing the other form of a line. So the slope intercept form of the equation of a line is an equation of a line with a slope m and the y-intercept of b. If you have the slope and you have the y-intercept, the equation of the line is y is equal to your slope m times x plus the y-intercept b. So if I'm given a point and I'm given the slope, but not, I don't know what the y-intercept is, I technically can plug in my y value, my slope, and my x value, my y and x value of that point, and find out what b is. And once I know what b is, I could have what the equation of the line is.